Today we're going to answer the question of why pi? Where did this 3.14159265 number come from? People of the ancient world knew pi was important, but they could never guessed how useful it would become. Today, scientists and engineers use pi for an amazing range of calculations involving circles and curves, from planning the routes of airliners to analyzing sound waves. And let's check out my dog Scoop enjoying a nice circular frisbee. Today we're going to do a mathematical experiment to find one of the biggest discoveries in all of math, and it's true for every circle. So our materials today are any circles. In this case, we're going to use bottle caps and some ribbon. You can use string. You can use whatever you want that is loose. And we have a ruler with the centimeter side. And what we're going to do is we're going to measure some properties of the circle. So we're going to measure the perimeter of the circle, called the circumference. Well, how do you measure the outside of a circle? I can't exactly bend my ruler. So I'm going to take a string and wrap it around. And I want to try and get it as tight as I can from tip to tail. Precision is key. Okay, got my string. Gonna lay it on my ruler, and the circumference of the blue bottle cap is 10 centimeters. And we're gonna study its relationship with the diameter, that is the line going from edge to edge in the circle. In this case, it is 3 centimeters. The diameter has to go through the center of the circle. And we're going to study the relationship between those two variables. We're going to do it for multiple circles. So now I'm going to do my medium circle. I wrap my string around. I make it as tight as I can. I measure from tip to tail, and it is about 15 centimeters in circumference, which is the perimeter. Let's again measure the diameter going through the center of the circle. It looks like it's 4.5 centimeters. And we're going to study the relationship between those two variables. As the diameter changes, so should the size of the circle. Let's do the big top now. I'm going to take my string. I'm going to wrap it all the way around, make it nice and tight so I can be precise in my measurements. And then I'm going to lay it across my ruler from tip to tail. And it looks like it's about 28 centimeters in circumference. And now I'm going to measure my diameter across the center of the circle. In this case, it looks like it's in between 8 and 9 centimeters, 8.5 and 9 centimeters. So I'm going to call that 8.7. Again, I'm not exactly being precise here, but I'm trying my best. So then what we're going to do is we are going to take our circumference and divide it by our diameter. And what we're going to find is there is a mathematical pattern that possibly holds true. 10 divided by 3 is 3 1/3. 3.3 repeating. If I do it for my medium-sized circle, I have 15 divided by 4.5. Oh my gosh, it's also 3 1/3 repeating. How the heck is this possible that two different sized circles would have the same relationship? Let's see if it holds true for our third circle. I'm going to take 28 and divide it by 8.7. And now I'm getting even more exact, 3.21. So how the heck is this possible? That when you take any size circumference and divide it by the diameter of that same circle, it ends up being 3 and change. If you'd like, we can do one more experiment. For this experiment, you need a toilet paper or a paper towel roll and something to measure it with. So in this case, I've actually found a paper clip, and the inside of that paper clip is pretty good at describing the diameter. So not from edge to edge, but that little inside piece. And then what I'm going to do is I'm going to take my paper towel roll or my toilet paper roll and cut it down the edge. And what we actually discover is that even without measuring, 1, 2, 3 diameters and a little more make up the circumference. 3 and a little more. I wonder what that little more is. And it took many, many years to discover, but this is why pi. So your big takeaways from today should be that pi is the circumference of a circle divided by its diameter. This formula can be rewritten as circumference equals pi times diameter, and since the diameter is worth 2 radiuses, we could also write it as circumference equals 2 pi r. And our big takeaway is that we can actually approximate pi. So the two things you will use to represent pi are either the decimal 3.14 or its fractional approximation 22/7. I hope you enjoy using pi the way Scoop enjoys chewing on a nice Frisbee.